When I was in school, resistors really gave me a hard time, but later I found that almost all the electronic devices I bought couldn't do without them. Today, let's see exactly how the resistor works. Simply put, the function of a resistor is to control the flow of current by providing resistance. The structure of the resistor is not particularly complex. Taking this axial resistor as an example, it consists of a resistive material spirally wound on a ceramic cylindrical core, with a layer of protective encapsulating material on the outside, usually ceramic or plastic. The resistive material is the core part of the resistor, generally made of a material with less conductivity, such as carbon, metal oxide, or metal wire. Different materials, as well as the length, density, cross-sectional area of the materials, determine different resistance values, and these values are marked on the external packaging material using color codes. If you look at a circuit on a microscopic level, the movement of electrons constitutes current. When electrons flow in a conductor, they collide with atoms and molecules in the conductor, making it difficult for electrons to flow. The role of the resistor is to provide this collision, thereby slowing down the speed of the current. The higher the resistance value, the more difficult it is for the current to flow through. If we compare the circuit to a highway where cars carry electrons, then the resistor is like a dirt road full of obstacles on the highway. The cars transporting electrons collide with obstacles and have to slow down to pass through. However, the collisions of electrons in the resistor cause some energy to be converted into heat and lost. If the heat is too high, it can even burn out the resistor. This is why resistors sometimes need cooling. In a circuit, the relationship between resistance, current, and voltage is the Ohm's law we are familiar with. The formula is as follows. So resistors in a circuit can function to limit current and reduce voltage. For example, LED lights, transistors, and other components may be damaged if the current is too high without appropriate resistors. Depending on the application, there are various types of resistors, such as fixed resistors, variable resistors, photoresistors, and thermistors. But there's a question. Since resistors dissipate energy, why must they be used in circuits? Can't we just set up a matching power supply? In fact, in a complex circuit, there are various circuit components such as LEDs. Motors, sensors, transistors, and so on have different requirements for current and voltage, but a single power supply cannot accommodate the voltage and current needs of all components. By adjusting the resistance, it is possible to provide each component with the proper current and power according to the circuit's needs, preventing components from being damaged due to overload. Although resistors cause some energy loss, this loss is acceptable and even negligible compared to the safety and stability of the circuit components.